So this webinar, as anticipated, is focused on the approach that we are using to check the quality of code of software with the tool named ETICS, and in particular, this presentation will focus will be presented in the context of the Ocean project, which is a project that is using ETICS to check the quality of FP7 outcomes. So I will first give a very brief introduction to the Ocean project. So the Ocean project is a support action funded by European Commission that aims to promote the collaboration between projects and the interoperability between projects, and the reuse of outcomes of these European projects. And one of the services offered by Ocean is a web directory with a number of research projects and their outcomes in terms of documents, deliverables, but also in terms of components and software components. And especially for these software components, Ocean is also categorizing these components basing on their interoperability capabilities and their in the quality of the software. And so we are using the ETICS tool to evaluate the quality of this software in order to be available on this directory, which is created by Ocean project. And this is actually important from our aspect, because one of the problems of research projects most of the times is that the software which is produced at the end of the project is a prototype, let's say, and it's very difficult to reuse this kind of prototypes, because after the end of the project there is no support to use the code. They are most of the time not very well documented, and they are not properly tested, and they don't follow standards in terms of interfaces, but also they have no standard packaging or a standard project structure that helps the reuse and evolution of this software. So in Ocean, we want to give an estimation of the quality of these components in order to be with basically two objectives. The first is to help the developers of these components to discover the quality capabilities of their components and potentially to improve the quality of their components. And the other objective is to actually give a criteria for choosing components to people that want to reuse this component instead of developing them from scratch. So I want to show very briefly the portal that Ocean is building. So this is the Open Cloud directory, which is the portal, the web directory that Ocean is maintaining. And as you can see, there is a number of projects here, and Ocean is focused on cloud assets, so in projects that deliver cloud components. And we have a number of projects registered. Most of them are research projects funded by the European Commission, but we have also some national projects and some Japanese projects also, because Ocean is part of the European-Japan collaboration program. And for each project, for instance, if I click on a project, I have a brief introduction to the project, and here I have the assets that this project is producing. And if we click on assets of type prototype of type software, as we can see, we have for the software, we have the description of the component, and we have some metadata for saying which is the programming language, with the positioning cloud stack of these components. And here in this section, we have the quality report produced by the ETICS tool. Concerning the quality model that we adopted in ETICS to evaluate the quality of software, it is based on SQALE. SQALE is a formal method to evaluate the quality of software starting from the source code of the software. It is compliant with these two standards, the ISO 9126 and the new ISO 21010, which is going to replace the old standard. And in particular, it takes the concept of characteristics from this standard. So the quality of a component can be seen from different point of view, from different characteristics. And SQALE and ETICS adopted these 8 characteristics that you can see on the right of the slide. So from testability, reliability, changeability, efficiency, security, maintainability, portability, and reusability. And so the concepts are really simple. So for each characteristic, we have a number of requirements that the source code needs to be compliant to have a good quality on the given characteristics. So the requirements of the source code are very low-level requirements, like I don't know, the length of source code files should be less than 1,000 lines, or all variables should start with a lowercase letter, or the method should be not too much complex, or should accept at most 7 parameters, something like this. And when we analyze the source code, for each violation of this source code requirement, we, I mean, the SQALE method and the implementation we did for ETICS compute the so-called technical debt, which is the estimated effort needed to fix the issues in the code in order to be compliant with the requirements decided by the model. So at the end, for each characteristic, we have a technical debt that says which is the effort needed to be compliant with all requirements stated in the model. And finally, we can also compute a rating, a quality rating that in this case, in this implementation, goes from A, which is the best, to E, which is the worst in this scale. And the rating is based on the technical depth that we computed for the component and the size of the component. Because of course, technical depth of 1 hour or 1,100 hours, let's say, on a component of 3 files, it's different from 100 hours in a component of 1,000 files, of course. And so the nice thing is that the quality rating is also a very immediate indicator of the quality of software. So it's very useful when checking the quality of a software. So as I said, the nice thing of this SQALE method is that first of all, it's very simple because there are very few concepts. I mean, the concepts of requirement, which are aggregated in characteristics, and for each requirement we have a technical depth. And the only aggregation function that we use is the sum. So it's really simple to compute the overall quality of a project, for instance, starting from the source files of its components. It's based only on the evaluation, on the analysis of source code, so it's fully automatable approach, and we can do it automatically in a continuous integration process while we are developing the code. And as I said, it gives information to programmers, because it detects the issues in the source code, so that programs can actually fix their code. And it's also useful to manager or to not that technical people that are involved in the project, because it gives this rating or and technical depth, which is a synthetic and immediate indicator for the quality of the source code. So now we will go a bit in depth in the ETICS tool and how to actually the ETICS tool works, and how it's possible to configure the tool to actually evaluate the quality of a given software. So ETICS is a build-end automation tool, and it's based on a web-based portal. From the portal, it's possible to configure the tool, execute builds, and see the results, and download the reports and the packages, everything. It's a really independent programming language or project structure, and so you can use it with different building tools, from Maven to Make, Rake for Ruby, for instance, or Ant, and so on. And of course, it can compile and build, analyze projects within different programming language, from C to Java, Python, Ruby, and so on. And it's able to manage dependencies between software components. They are useful when analyzing the code, but also when building the code, because you can instruct ETICS how to actually find the dependencies that the code needs in order to be compiled. And as I said, there is also a repository where all the reports and all the packages are stored in different formats, because the tool is able to create distribution packages in different formats depending on the platform. So we have the classical targzeta, but we have also platform dependence binaries like Debian packages or RPM in case of Red Hat infrastructure architecture, and so on. And it's also extendable through the use of plugin that we will see in a moment. And now I wanted to just show the portal. So this is the portal. It's reachable at this address here. Let's start with the configuration. So this is the configuration of the tool. Here we have the projects, which are actually they are in a tree structure. We have a project which is composed by subsystem and components, and we have subsystem which they are composed by components. For each component, we have all the commands, all the configuration that we need for check out and build the component and analyze the code. So once you created the structure in here, you have to instruct ETICS how to take the code from the source code repository, which can be a Subversion repository or a GitHub or a CVS and so on. And you have to instruct and you have to specify the commands that are required to compile the code. So if we see these projects here, for instance, here we specify which is the source code repository. In this case, we have GitHub, so we can edit the information here, and we then specify the commands to check out the code. In this case, we are using the Subversion subversion connector for GitHub to get the code, and we then specify the commands for building the code. And in this case, it's a Java component which is using Maven, so we just say Maven install. How do you, the same way you would do in your local machine, in your computer. And then we specify also the dependencies that this component has towards external components or other components in the same projects. So in this case, we say JDK, and because it's a Java component, and Maven because it's using Maven. Once we configured everything, we can see this other section, which is the section for submission of the builds. So this is let's say a snapshot of the status of the ETICS infrastructure. So this is the pool of ETICS machines that are used for compiling the code and for executing the test. As you can see, we have different platforms, so the same code can be built on different platforms to check that everything is fine for this platform, and to create distribution packages for all these different platforms. So we have here a panel with the recent submissions. That is the same we can see here in this other panel here. So when you submit a build, for instance, I did this yesterday, you see all the information, and we can see the logs. This is the report of of the build, and we have also the actual log on the machine that executed the build. This is useful when debugging issues most of the time. And but what we are interested today is the quality analysis, which is reachable from here. So for each component that we built in our code, in the ETICS infrastructure, we have this report, which says actually, which is a summary of the quality analysis based on the SQALE method that we did, that we presented before. So we have a summary for the technical debt for the component, which is actually, as I said, the estimated effort needed to make this component compliant with all the quality requirements that we set. If we click, we can go in depth into the code, and we have, for instance, all the files that are in that component, and we have here the technical depth for each file, and we have the rating for each file here. And if we click, we can go on the level of class and discover, for instance, that this class have a coupling which is too high, 24, when the maximum allowed was 7. And here we have a hint, let's say, to solve this code and these issues, and we have also estimated time to solve, required for solving the issue. For instance, here we can see there are some duplicated lines in the files, and again the coupling. Let's see if I can find different issues. We can search also. Okay, for instance, I searched for complexity, and I found that the create method in this class architecture factory imp class in this file is too complex, because it has a cyclomatic complexity which is 18, which is higher than the threshold that we set, that was 10. Okay, here, in this slide, okay, we didn't see these aspects, but I mean, all these analysis, quality analysis, are made by some specialized tool for static analysis of the source code, and they are check style or find bugs or PMD for Java, which are tools that analyze the code and extract issues and extract metrics for the code. And then ETICS takes these metrics and it's able to use that for computing the scale analysis and the scale reports and the quality ratings. Okay, I show this in the live demo. Okay, so this analysis is, as I said, is performed once you configured your component. You can submit a manual build. I mean, from the portal, you can say, I want to build this component here. I click on here. I select the platform where I want to make my build and my analysis, and I click run. And then we should be able to see in this other panel the build which is appearing. Here it is. And but ETICS, we developed also some hooks that are able to detect changes in the repository, in the source code repository, or changes in the configuration of the tool. So every time we change, every time we change something on the repository, for instance, we do a commit on our subversion, or every time we change something in ETICS, adding a dependencies or changing the build commands or the version of the components, ETICS is able to detect these issues, these changes, and to trigger a build that run the analysis again to check that everything is fine after the changes. And all the information that we see, all the reports that we saw in this presentation, for instance, the scale reports, but also the charts and that we saw at the beginning, are actually kept updated with the last analysis performance. So if we go back here, these charts are actually kept updated with the last changes in the code. So these are images that are generated by the ETICS server, and which are you can use a REST interface to actually embed these images in, as we did in this project. In this page, you can embed in any web page, and they are always updated with the last changes, as I said. So coming back to Ocean projects, we are exploiting the capabilities of this ETICS tool in order to make analysis of these FP7 projects. We did some analysis already, and we are going to analyze more projects and to publish the results on the open cloud directory that we saw before. And with the main objective of, as I said, to be able from the directory to have a immediate and synthetic evaluation of the quality of that prototype, in case you want to reuse it, or in case you want to improve the quality of that code. Of course, we give priority to projects that are still running and that are in a development phase, because the benefits, one of the benefits of checking the quality of the source code is actually that you can actually fix and improve the quality with a very few effort, because thanks to analysis like the one done by ETICS, it's very simple to identify the quality issues. I mean, to identify issues in the source code that drive to a bad quality software and to fix them. Okay, this is my last slide. I hope I'm on time. And well, some reference for the ETICS tool, the website, the Open Cloud Directory, and my email in case you want to contact me.